Today, we are getting into the weeds of the Kubernetes pod lifecycle. We're going to talk about how you can master the startup, the execution, and maybe most importantly, the shutdown of your pods to build apps that are genuinely tough and reliable.
Look, if you've spent any time with Kubernetes, you have absolutely asked yourself this question. You're just staring at the terminal, watching your app fail over and over and over again, and you just think, what is going on here? And then you see it, that dreaded status message, crash loop, back off. We've all been there. And you got to understand, this isn't just some random bug. It is a massive red flag. It's a symptom that your application is in a street fight with the chaotic world of a distributed system, and right now, it's losing.
So let's dive into that. We're going to start by figuring out why this chaos even happens in the first place. Because once you get that, you'll see how Kubernetes gives us some really elegant tools to wrestle that chaos into submission and get our apps starting smoothly every single time.
Okay, here's the core of the problem. On an old-school server, things boot up nicely, one after the other. But a Kubernetes pod, it's a free-for-all. Your main app, any sidecar containers, everything just tries to start at the exact same time. And this creates a classic race condition, where your app is up and running, trying to connect to a database that isn't ready yet, or looking for a config file that doesn't even exist.
So how do we fix this mess? Well, that brings us to our first and honestly most powerful tool for taming this startup chaos, the Init Container. This is how we bring some much-needed order to the very beginning of our pod's life.
The best way to think about an init container is like a stage crew for a rock concert. It's the special, separate container that has one job: get everything ready. It runs, it does its setup tasks, and it must finish successfully before your main application is even allowed to take the stage. It's all about handling those prerequisites.
And this right here is their superpower. They run in a sequence. You can have a whole list of them, and Kubernetes guarantees it will run them one by one in the exact order you set. So first, it waits for the database. Done. Then it generates the config file. Done. Then it runs a migration. Done. And only when that entire chain of success is complete does your main app get the green light. The race condition is, well, it's just gone.
This really shows you the difference in philosophy. The old way meant stuffing all this complex retry logic and networking tools right into your main application. It made your app bloated, complicated, and your logs were a mess. The Kubernetes way? You just offload all that dirty work to a tiny, simple init container that disappears when it's done. It's just so much cleaner.
And this clean separation lets you do some really powerful stuff. You can have an init container that just waits for a database to be ready, or maybe one that clones a Git repo to populate a volume with some assets. You can even use them to safely run database migrations before your app starts, or to generate config files on the fly. The possibilities are huge.
All right, so our app startup is solid now, thanks to init containers. But that's only half the story, isn't it? What about the rest of the container's life, especially when it's time to shut down? For that, we need a different kind of tool. We need lifecycle hooks.
So what are they? Basically, lifecycle hooks are your way of telling Kubernetes, hey, I need you to run this specific command for me at a very specific moment. And there are two of these critical moments: postStart, which happens right after your container gets created, and preStop, which happens just before your container gets terminated.
Now, the difference between these two is absolutely critical. The postStart hook fires off at the same time as your app, so it's asynchronous. It's great for things that are nice to have, like warming up a cache. But the real game changer, the one that solves so many headaches, is preStop. It runs before your container gets the termination signal, and it blocks that signal until it's done. That's the secret to a graceful shutdown.
And this brings us to one of the holy grails of running services in production, the truly, genuinely zero downtime deployment. It's something that has kept operations teams awake at night for years, and we're about to see the secret.
Oh, I bet you felt this pain. You roll out a change, your deployment says it was a success, everything looks green, but then you check your monitoring and it's lit up with 502 bad gateway errors. Your users are seeing failures, and you're left scratching your head. It's all because of a hidden race condition that happens during shutdown.
So here's the race. When Kubernetes decides to terminate a pod, two things kick off at once. The network starts removing the pod from the load balancer, which takes a few seconds to ripple across the cluster. At the exact same time, the container itself gets the signal to shut down, which happens almost instantly. So your container can be completely dead before the network even knows it's supposed to stop sending traffic to it. And that's it. That's your 502 error.
The load balancer is just doing its job, sending a request to what it thinks is a perfectly healthy pod. But surprise, that pod is already gone, or it's in the middle of shutting down and can't accept new connections.
So what's the elegant solution to this complex networking race condition? Well, you're looking at it. It's this one simple preStop hook. All we're doing is telling Kubernetes, hey, when you decide to kill this pod, just wait. Pause for 15 seconds before you even tell my app to shut down. That little delay is all the network needs to catch up, drain the traffic, and ensure no user requests get dropped. It's beautiful, isn't it?
Okay, one really important gotcha here. You have to remember that this sleep time counts against the pod's total shutdown clock, which is called termination grace period seconds. So you have to make sure that this grace period is long enough to handle both your preStop sleep command plus however long your application actually takes to shut down cleanly.
All right, let's put this all together. When you combine these two ideas, using Init Containers to guarantee a clean start and using Lifecycle hooks to guarantee a graceful exit, you really start to see the whole picture. You're moving beyond just running your app to actually orchestrating it.
So here it is, your pod lifecycle toolkit. Init Containers bring order to the chaos of startup. The postStart hook is there for any optional warm-up tasks you might have, and the preStop hook, that's the guardian of your graceful shutdown. When you use these together, you've got the entire lifecycle covered, from a perfect start to a flawless zero downtime finish.
So I'll leave you with this one question to think about for your own services. Is your application just running? Is it just getting by, hoping for the best on every deployment? Or is it truly resilient? Is it using these tools to gracefully handle the constant change of a cloud environment? Because that, right there, is the difference between a good application and a great one.